Hello, my dear friends. Alright, hello everyone. So in this video, I'm actually going to show you the same problem, and this time we're going to do the optimized version. So last time we had this the quadratic time complexity with a constant space complexity. And we got into the point where do I need to optimize this? So let's actually see the algorithm in its optimized version. I'm going to go into Paint here, and I'm going to start with my painting skills once again. Okay, so hopefully you remember our last problem. Just to recap, our time complexity of the last problem was actually quadratic, and we're going to be aiming to make this linear, meaning that we're going to be aiming for this. Now, in order to make this, usually, right, you need to compromise something else. So this to create a linear time, you usually need to stash some things. That's called caching, which is going to be performing on our space complexity, right? So you need to sacrifice one for the other. So our space complexity is going to grow as well, but our time complexity is going to drop down. So the functions that we're going to be aiming is this is going to be our time, and this is going to have a linear view, and sadly, space is not going to be this. It's going to be this. Right. So they're going to be growing linearly. Right. Well, that said, it's not a problem because we are still showing that we can optimize one at the cost of other. Usually this shows that you are understanding algorithms in a bit deeper level. It's very good to show them in interviews, and it's always good to show the graph, the mathematical graph, because you can actually visualize the algorithm. So let's actually see how are we going to do it. I'm going to write a couple of numbers. Now, I'm not sure if these are the numbers that I used in the last video, but it doesn't really matter. One thing that we can do is create a set. So I'm going to create my set over here. That's quite a big one. I don't need that big actually. So I'm going to store. So we're going to iterate through the collection again, and I'm going to be storing the value. So values here, and I'm going to write them like that. So these are going to be values. And what are these? So these need to be the indexes, right? So these are going to be the positions. So I'm just going to say position. These are going to be the positions in our collections. All right, sorry for this. I can't really write with my mouse, but I'm going to do my best. So positions. Okay. So with one look in our collection, you can actually write the positions on your own, which are very simple. And now, in order to explain it, these are our array positions, right? So 11 is found at the index 0, 15 at index 1, and so on and so forth. Once you actually have this set, you can iterate through it and you can test if you have the things that you're going to be looking for. These are called two passes because we need one pass here, so one pass which is going to be linear again, and one pass here, so one pass here, and one pass to the set that we created, which is also going to be linear, meaning that we're going to have big O of 2n, doesn't matter the 2 since we're not looking at constants, and we are going to have big O of n. Okay, so that's good, but what I'm going to be trying to do now is to create this in one pass. So I'm going to do this, and now if I zoom here on the right, okay, good. Oh yeah, that's actually very good. So now it's like a new window. So let's actually go and create the collection again. 11, 15, 2, and 7, and I'm going to walk you through the algo. So I'm gonna be using this set again. So I'm gonna write my set, hopefully better than the last one. Okay, and I'm gonna create my set. In order to do it in one pass, it means that we need to check and we need to alter the collection at the same time. So how are we going to do it? Let's take 11 and I'm going to check if our target, so I'm going to say if our target minus the current number. So I'm going to say current, and again, very difficult, current, right? If this is found in our collection. Is this found? Obviously, at the first element, this is not going to be found. So I'm going to write 11, and then I'm going to write where I found it at position 0. 11, 9 minus 11 is equal to minus 2. If I have minus 2, it means that 11 plus minus 2 is going to give us the target. So minus 2 is actually a valid candidate, and I can have the possibility to take the index of this minus 2 if I have it in the collection and return it as a set. So this is going to be completely valid, and these are the things that we're going to be doing. But currently we don't have anything, so I'm just in the collection, so I'm just going to say 11 and the position 0. I'm going to move my pointer to the right, and I'm going to have 15. So 9 minus 15 is going to give me minus 6. And again, do I have this in the set? I don't. So I'm going to write 15. If I don't have anything in the set, I'm not returning. I'm just going to write it into it, out of the collection, in the set collection. And I'm going to say, yeah, this is found in index 1. So I'm going to increment the pointer again. I'm going to get 2. And now I'm going to say target minus 2 is equal to 7. Do I have this in the collection? Now I do have it here, but I don't know anything about 7 in my set currently. So my answer here is no. As I say no, I'm going to add 2 with its own index, which is going to be 2. And I'm going to move my pointer once again to the end of the collection. I'm going to move it and I'm going to get 7. And this time, I'm going to say 9 minus 7. Do I have this in the collection? This is equal to 2. Well, I do have a key 2, right? And the key 2 is actually having an index 2. So this time, I have the complete freedom to return the index that I found this 7 now, which is going to be 3. And also where I found this 2 in my collection. I stored the index at 2, so I'm going to return 3 and 2. Right, so that's pretty much the algorithm. Keep in mind, very important, one last thing, because we got very long, is that you cannot do nums minus target, because this is not going to be a valid thing. You want this thing plus this thing to give you target, because in the maths, a plus b is equal to b plus a, right? But a minus b is not equal to b minus a. So you need to be very careful of that. Let's go to LeetCode and see how it's done. Okay, we're back in the LeetCode, and I'm going to do an exact translation of the algorithm that I explained. So our dictionary, since we need to create the set, and in order I can just say set here to keep it relevant to the picture that I depicted, is equal to a new dictionary, and we're going to be storing the value and the index where we found it. So these are both nums, ints. Next, I need to iterate, so I'm going to write for, and I'm going to say current index equals 0, current index is less than nums.length, and of course current index plus plus. Okay, so now we have the going forward motion, and now I need to check if we have it in the set. If we don't have it, we're just going to set it, and if we have it, we're going to return. I'm going to steal an idea. I'm not going to create a list here, the output array. I'm going to create it dynamically. So I'm going to check if the dictionary, actually our set, is containing, so it contains key, and does it contain the target minus the nums of current index that we were talking about. Now, if this actually contains it, it means that I already have something on the set that's going to say, yeah, we have the correct solution, which pretty much we're set to go, right? We have the complete possibility to have a valid answer. Actually, we do have a valid answer at this point. So all I need to do is to return it. I'm going to say var second place, or second index, is going to be equal to our dictionary, not dictionary again, our set of target minus nums current index. we can do this because we know that it's valid. Otherwise, we're going to get an exception. But I know that it's valid here. So I'm going to go with that. And I'm going to return a new int. And I'm just going to store the second index and the current index. And if you actually want to look good, you can just put current index here and second index in the second place. Keep in mind that it doesn't matter because we say that order, you can return the answer in any order. So that's pretty much, it doesn't really matter what you do here. It's just for preference. Otherwise, what I'm going to do, obviously, I don't have anything to the set, so I'm just going to add it. Again, dictionary. Set of the current number, so nums index, is going to be equal to the index of where it is found in our original collection. So that's pretty much index. And if I haven't found anything, I'm just going to return no. Okay, so that's pretty much the algorithm. Let's actually run the code. Running code is going to run with these three examples. And we are going to see that we have an error, all right? The name index doesn't exist. Yes, it does not because it's current index. Okay, and let's run again. So running code is going to give you the three tests here, so the three examples. And now when we submit, you're going to send it to the server and see if actually you're going to pass everything. So there we go. Now it's actually run, it says that it's running 49% faster than everyone else. I'm just going to submit it again. Keep in mind that this is actually, this depends on how heavy the server is actually at the moment. So you need to be very careful. If you want to see how fast it runs, you can use benchmark.net, and it's something that I'm going to show in further videos. And just for the sake of it, let's actually do it in JavaScript as well. Because I want to practice the JavaScript as well. Now JavaScript is going to be the same thing. What I'm going to do is I'm even going to copy this. So I'm going to copy this very quickly, put it in JavaScript as a comment, in order just to see if something is failing, to see where, just to be a bit quicker. So we want to create a dictionary again. This in JavaScript is actually easier. So I'm just going to say let dictionary is going to be equal to an empty one. And I'm going to create an output. Do I actually need to? Do I need to? Yeah, I need to. So I'm going to create an output as an empty array. I think I'm going to need this one because here I can return no. In JavaScript, I don't know if this no is actually going to work. So I'm just going to return an empty array. Okay, so I'm going to do the for loop. So we are here currently. And for loop, pretty much the same thing. Let's current index equals 0. Current index is less than our nums dot length, and current index plus plus. Incrementing it. What we want to check is, do we actually have the target in our set, or do we need to continue building the set, right? So that's fairly easy. I'm going to create a lookup. So I'm going to say lookup number. That's going to go to our target minus nums. I don't know how to say contains key in JavaScript, so I'm just going to say lookup number, and I'm going to create it as nums of our current index. So once I actually have the lookup number, now I can say if lookup number is in our dictionary that we created. If that is the case, it means that we have found something in the set with the current index. So I have the freedom to return a value. And I'm going to return the dictionary of the lookup number since I know it exists. Keep in mind that's very important, otherwise you're going to end up with an exception. And the second parameter is going to be current index. Okay, good. If I don't have it, I just need to build the set, continue building the set. So that's pretty much the same thing as here. Exactly the same thing actually. So dictionary of nums of current index is going to be equal to current index. Okay, and here I want to return output if I have not reached this line. So let's run code again and see if that's going to work. It does, and let's submit and see if that's going to work. All right, well, there it is on JavaScript and C# this was the optimized version. Thank you for watching. Stay tuned for the next one. And yeah, like and subscribe, share if you found this useful, and we're going to see each other in the next one. Bye.